Okay, so today's lesson is lesson 7 on the quadratic formula. It's section 4.7 in your book, and our content objective is to solve equations by using the quadratic formula and determine the number of solutions by using the discriminant. Language objective is to use the correct terminology to explain the quadratic formula. So let's talk about what that is. So first thing, quadratic formula. We use the quadratic formula to solve for our x-intercepts. So it solves for x values. As I mentioned at the beginning, earlier in this unit, we learned 3 ways to solve for our x-intercepts. The first was factoring, the second was completing the square, and now we're doing the third method, quadratic formula. So we're going to use this as a catch-all way to solve for x-intercepts. If you're ever unsure what to do, quadratic formula is an easy place to look or to try. It is derived by completing the square with standard form. So to derive it, you'd start with y equals ax squared plus bx plus c. Plug in 0 for y and then solve out for x. So if you want to try that, put a little star here, bonus points. If you are able to do that, I can show you in class if you are so interested. I think it's a really cool process, and I think you can do it on your own if you are comfortable completing the square. So I'd encourage you to try it on your own. But for the sake of time, I'm not going to do this in our notes. So I'm just going to write what this quadratic formula is because we're going to spend most of the notes today using it. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is our quadratic formula. It's going to come up a lot. You should know it really well. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's practice using it. For our first example, I want us to determine what are the solutions. And I want us to use the quadratic formula. So we could solve these out by completing the square. But we're going to practice using quadratic formula. So we have 2x squared minus x equals 4. So first step 1, we're going to rearrange into standard form. So since I'm talking about a, b, and c values, I know that I want this to be in standard form. If you look at this formula, we have a, b, and c, so I want this to be in standard form. So if I rearrange that, I get 2x squared minus x. I'm going to subtract 4 to the other side. So minus 4 equals 0. So now I have my standard form. So I'm going to identify a, b, and c. So here a is equal to 2, b is equal to -1, and c is equal to -4. So I'm going to go ahead and substitute that into my quadratic formula. So when I substitute that into quadratic formula, I get x is equal to -1 plus or minus the square root of -1 squared minus 4 times 2 times -4 all over 2 times 2. So that might look pretty messy, but most of this is just multiplying and evaluating exponents. So my next step is going to be to simplify. So when I do that, -1 I know is equal to +1. I keep my plus or minus since I can have a negative or positive solution to a square root. That's how we get our 2 solutions if we need to for our quadratic. So then -1 squared is +1. -4 times 2 is -8 times -4 is +32. So I have 1 plus 32 all over 2 times 2 is 4. This isn't quite simplified. I can do one more step. So I end up getting x is equal to 1 plus or minus the square root of 33 over 4. I can't simplify that anymore because there's no way to simplify the things outside the radical, and the radical can't be simplified either. So this is my final solution. If in the context of the problem you would prefer a decimal answer, you could evaluate this and get your 2 solutions, adding the square root of 33 and then subtracting it. But for the sake of this problem, unless you need to simplify for some reason to get an answer that's easier to work with than this current form, this is an acceptable solution. It's the most precise since there's no rounded decimals. So that's using the quadratic formula. We're going to do a quick check to make sure we're all on the same page. So I'm going to flip the page for that. So again, I want you to find the solutions using the quadratic formula for x squared plus 6x plus 9 equals 0. So go ahead, try that one on your own. I'm going to go over it now. So I do not need to rearrange this into standard form because it is already in standard form. So then I just identify my a, b, and c values. In this case, a is 1, b is positive 6, and c is positive 9. So since I have those, I'm going to go ahead and substitute into quadratic formula. So I have x is equal to negative b, which is negative 6, plus or minus the square root of 6 squared minus 4 times 1 times 9, or 4 times a times c, all of that over 2 times 1. If I simplify that, I get negative 6 plus or minus the square root of 36 minus 4 times 1 is 4 times 9 is 36, all over 2. 36 minus 36 is actually just 0, so I have negative 6 plus or minus the square root of 0 over 2. Square root of 0 is just 0, so I end up with x is equal to negative 6 over 2. So x is just equal to negative 3. And that is my only solution for that, since the plus or minus was more or less canceled out or for no longer relevant when I took the square root of 0. So that is my final answer. We'll have some more practice with this in class, but there's another piece I want to go over with you guys called the discriminant. So the discriminant is the part of the quadratic formula under the radical. So the radical again is our square root sign. So the discriminant is equal to this part, which is b squared minus 4ac. So our discriminant is b squared minus 4ac. And the reason we're talking about this is because our discriminant tells us how many solutions our quadratic will have. Since, as we practiced yesterday, we know we can't, or a positive square root will give or if we have a positive number under the radical, we'll have 2 solutions because we'll take the positive solution or the negative solution. But if we get 0, we'll only have 1 solution, since plus or minus 0 is going to be the same either way. And if we have a negative solution, we can't take the square root, so we'll have no solutions. So to sort of consolidate that concept into a table, I'm going to write over here, our little table showing us the different ways or how our discriminant will tell us the number of solutions we have. So if our discriminant, b squared minus 4ac, is greater than 0, we're going to have 2 real solutions. So we have 2 real solutions because our graph will ultimately either open up and cross the x-axis twice or open down and cross the x-axis twice. So there'll be 2 x-intercepts. Because we'll have our plus, or we can take the square root and then we'll have plus or minus, we're going to end up with 2 x-intercepts or 2 real solutions. If our discriminant b squared minus 4ac is just equal to 0, not greater than, but actually just equal to, we're going to have 1 real solution. So just like our last quick check, we only got 1 solution because our discriminant was 0. In these situations, our graph would look something like this. Either it opens down and touches it once, or it opens up and touches the x-axis once. So there's 1 x-intercept. So for discriminant 0, plus or minus 0 is going to be the same thing. So we're going to have 1 x-intercept. There's only 1 solution, like our quick check. The last case we haven't seen yet, but is just as common. We have b squared minus 4ac is less than 0. So less than 0 means it's a negative number. If we have a negative number for our discriminant, we're going to have no real solutions. And as you may know, we'll have imaginary solutions, but we'll talk about that later in this unit. We're going to have no real solutions, which means we will have no x-intercepts. So our quadratic will never go through the x-axis. It could still open up or down, but it will never cross the x-axis, so there are no x-intercepts. And that's when our discriminant, or what's under the square root, is a negative number. So positive, we get two solutions, the plus or minus solution. Equal to 0, there's only one solution because plus or minus 0 is the same thing. And if it's a negative, then we can't have a solution because we can't take the square root of a negative. So we're going to do a quick check with that just to make sure everyone's understanding what I'm talking about. So I want to know how many real solutions are there for the equation negative 2x squared minus 3x plus 5 equals 0. So using your discriminant, I want you to figure that out. Try it on your own. I'm going to go over it now. So again, I'm going to identify A, B, and C. So here my A value is negative 2, my B value is negative 3, and my C value is 5. So if I plug into B squared minus 4AC, I get negative 3 squared minus 4 times negative 2 times 5. If I calculate that out, negative 3 squared is positive 9. Negative 4 times negative 2 is positive 8 times 4 is 40. So I have plus 40, which is equal to 49. So since that is a positive number, I'm going to have, so therefore there are two real solutions. So you don't actually have to calculate this all the way out unless I'm asking you for those solutions. All I want you to know is how many there were. So in this case, I know there are two real solutions since my discriminant gives me a positive number. So that's all for today's notes. Make sure you write down any questions, comments, or concerns you have so we can go over them together in class.